When dealing with absolute values and inequalities, we have to be a little more careful, and there's two major things that we need to look at. First off, there's two real types of inequalities. Absolute value of x less than c and absolute value of x greater than c. And of course, you can replace the less than with less than or equal to, and the same thing with the greater than. So this first one really wants to know what numbers have a distance from 0 of less than c. And this is actually going to translate into the compound inequality negative c less than x less than c. The one on the right wants to know what numbers are further away than c from 0. This one ends up being x is less than negative c or x is greater than c. So we really have to pay attention to which one of these situations that we're in order to know which inequality to solve. Absolute value of x plus 2 is less than 5. So this is the less than case. And for the less than case, the rule is negative, that number, less than, what's in absolute values, less than 5. I can subtract 2, and I get negative 7 is less than x is less than 3, which we can graph. I do not include my endpoints, so open dots, and we would shade in the middle. Absolute value of 2x plus 5 is less than or equal to 3. Once again, we're in the less than case, so I would have negative 3. Less than or equal to 2x plus 5 is less than or equal to 3. I can subtract 5 from all three sides. That's negative 8 less than or equal to 2x less than or equal to negative 2. Then I divide all three sides by 2 to get negative 4 less than or equal to x less than or equal to negative 1. We can graph this. Since we're less than or equal to, we use closed dots to indicate that we're going to include those points and shade in the middle. My next one, absolute value of 3x plus 4 greater than or equal to 2. This is our greater than or equal to case. So the rule says we have 3x plus 4 less than or equal to negative 2, or 3x plus 4 greater than or equal to 2. For the left-hand side, I'm going to subtract 4 from both sides. That gives me negative 3x is less than minus 6. Divide by 3 to get x less than or equal to minus 2. On the right, I can subtract 4 from both sides. I get 3x is greater than or equal to negative 2. Dividing by 3 gives me x is greater than or equal to minus 2/3. So if I want to graph this, since I used a greater than or equal to and a less than or equal to, I'm going to include the points. I want it to be smaller than negative 2 or bigger than 2/3. 2 times the absolute value of x minus 3 is greater than 6. My first step would be to get the absolute value by itself, so I'll divide by 2 to get absolute value of x minus 3 is greater than 3. Since we're using a greater than, I have x minus 3 is less than negative 3, or x minus 3 is greater than 3. I'll add 3 to both sides to get x less than 0. And over here, I'll add 3 to both sides to get x is greater than 6. I don't include 0 and 6, so open dots. And I want it to be less than 0, so to the left of 0, or bigger than 6, so to the right of 6.